Linear correlation, the PMCC. The product moment correlation coefficient, shortened to the PMCC, is a measure of the strength of the linear relationship between two variables, for example height versus weight on a scatter graph. And it measures how close data fits to a straight line, hence the linear relationship, linear correlation. The PMCC is represented by the letter R, and R can take any value between -1 and +1 on this scale. So an R value of 0 shows there is no correlation between two variables on a scatter graph. And you've got positive correlation, and then you've got negative correlation. So we're using a numerical value on this scale to represent the strength of correlation and whether the correlation is positive or negative, instead of the usual wording that we use where if we have strong positive correlation, weak positive correlation, no correlation, weak negative correlation, weak positive correlation. So we're actually quantifying the strength of the correlation rather than just giving word descriptions. So some examples. So if the R value is 1, every single point lies on a straight line, and we have a positive gradient on this regression line. So we're down here on our scale of -1 to +1, so R equals 1, R equals 0.3, no correlation, R is 0, R equals -0.8, so strong negative correlation, and we have perfect negative correlation. Every point is on a straight line, the gradient of the line is negative. Here are some more examples of scatter graphs with their corresponding R value, their PMCC value, and the regression line in each one, the line of best fit, and more examples. So on this scale, a value of R in this range, -0.1 to 0.1, it's close to 0, so we say there's no correlation between the two given variables. And then we have weak correlation, weak positive, weak negative, moderate positive correlation, moderate negative correlation, and then we have strong positive correlation and strong negative correlation. Example 1. We're given the test scores as percentages for students who've sat both a maths and physics paper. So for example, this represents a single student. The student scored 59% in maths, 65% in physics. Another student here, so the same student scored 18% in maths and 22% in physics. So we can represent this data on a scatter graph, which looks like this, and we can see that there is some kind of linear correlation here. So working out the PMCC would be the next step. And remember, the PMCC works out the strength of linear correlation. So to enter the data, so menu, option 6, and then y equals a plus bx, that's an equation of a straight line for linear regression, and we enter the data. So enter your data one column at a time. So that's the last value in the first column entered. Scroll down and across, and now we enter the physics scores, and that's the last one entered there. Once your data's in, you can double check things. It's a good idea to do so, and then press the AC key. The data is still in there. Options, and we're doing regression calculations, option 3, and y equals a plus bx is the equation of the regression line, the line of best fit that goes through the data on the scatter graph, and our PMCC values here, R equals 0.906. So this value is telling us that we have strong positive correlation, but we need to use the context as well, so between maths and physics test scores. So the equation of the regression line that I can draw on this scatter graph, so from y equals a plus bx, on the y-axis I've got physics, so I'm just going to call that P, is equal to A, which is 10.8, plus b, which is 0.915, times x. On the x-axis I've got maths, I'll call that m. So now I'm going to draw this line on the scatter graph. To draw a line we need 2 points, so I've chosen m equals 0, so down here m equals 0, so you put in m equals 0, you've got p equals 10.8, so here's that point, and mark that point different to the other points because it's not a part of the original data, it's something extra that you've added onto the graph. And I've chosen something at this end here, 80, so m equals 80, substitute 80 in here, and we get p equals 84, this point here. So now we need to draw a straight line through those points, like so.